So we're going to talk about Pascal as well. Okay, so let's start with Fermat. I'm going to draw a right triangle right here. I'm going to call this A, I'm going to call this B, I'm going to call that C. Okay, A, B, C. And I'm going to call A 3, B 4, and C 5. Okay, so what that means is basically each of those letters represents one of those. Does that make sense? Right, Sully? Can you see how that flows? So A represents 3, B represents 4, and C represents 5. So in math, we can use letters to represent numbers, and that's legal. That's not illegal, okay? That's sort of the birth of algebra. Algebra was born around 600 AD. It actually came from Baghdad in Iraq, from a librarian. So that's a little bit where algebra comes from. But the idea of algebra is that you can take a letter and use it to represent numbers, okay? And so if it's 3, 4, 5, then there's this guy, another guy that came around 500 BC called Pythagoras. Pythagoras was a Greek mathematician who said that basically, well, other people might have said this, but we call it the Pythagoras theorem. And the Pythagoras theorem says, if you take a number and square it, and add it to another number and square it, in this case, a right triangle, then those two numbers squared will add up to a third number squared. So A squared plus B squared is equal to C squared. That's what Pythagoras said. Anyone ever heard of Pythagoras theorem? You can just show by hand. Okay. So Pythagoras theorem basically says if you take 3 squared, for example, and you do plus 4 squared, your answer will equal 5 squared. Well, is that true? Let's find out. What is 3 squared? 9. What is 4 squared? 16. What is 5 squared? 25. What is 9 plus 16? 25, right? So 25 is equal to 25. Check. That's true. In a right triangle, the square of the legs, these are called the legs. So you're going to call this leg 1 and leg 2, and we call this the hypotenuse. Okay, so what Pythagoras theorem says is the square of the first leg plus the square of the second leg equals the hypotenuse squared. Okay, that's a fact. Nobody questions that. In a right triangle, that's true. And there's something in math called the converse. The converse in math means if you do it the reverse way. So let's watch this, and then we'll come back and calm down. Okay? If you take a right triangle and square the leg, and then you take the other leg and you square it, you add them together, they'll give you the hypotenuse squared. Okay, now let's talk about the converse. If you find a right triangle, if you find a triangle, you don't know if it's a right triangle. You just know it's a triangle. And if you take this triangle and it has some value like 5, and it has another value like 12, and you do the same thing we discussed, and you get a value of 13. If you find a triangle that the square of the legs equals the square of the hypotenuse, that triangle is a right triangle. Okay, watch how it goes. If you're a right triangle, your legs squared will give you a hypotenuse squared. If you're a triangle, and I don't know what you are, but your legs squared gives the hypotenuse squared, then you are a right triangle. Do you see what's called a converse? Because not every statement is true, and its reverse on doing is also true. If you play basketball, let's take it back. If you're tall, you play basketball. I'm going to give an example. Let's just assume it's a universe where everybody who's tall plays basketball, okay? And I play basketball. I'm a point guard. I'm not tall, but I play basketball. But let's just say in a universe where if you're tall, you play basketball, right? But is it true that if you play basketball, you're tall? Not necessarily. Those are not necessarily true. But in this case of the Pythagoras theorem, the converse is true such that if you are a right triangle, your legs squared will equal your hypotenuse squared. And if your legs squared equals your hypotenuse squared, you're a right triangle. That stayed true for years. Remember, Pythagoras lived about 500 BC during the time of Daniel or so. Then we fast forward to the origin of algebra, which is around 600 AD. So about 1,000 years between Pythagoras and the origin of algebra. Then add another 1,000 years, a man by the name of Fermat comes. And Fermat, the French mathematician, Pierre de Fermat, said, this is true only if you're doing it for squares, but it will not be true if you do it for cubes. There is never a number cubed plus another number cubed that will give you an answer cubed. I don't think, when you think about what he's saying, he's basically saying that Pythagoras' theorem is true, right? If it's a squared plus b squared equals c squared. But here's where the theorem gets crazy. He says, but it will never work for any number apart from squares. Do you know how powerful this word is? Never means no exceptions. Think about this for a second. Imagine if I came to you and I said, you will never find a black swan in our universe. Is that pretty audacious? Is that pretty bold of a statement? It's pretty bold. Because what I'm telling you is no matter where you go in the universe, you will never find it. What Fermat is saying is you will never find a number raised to a power plus a number raised to that same power that will equal a number to a power for anything greater than a squared. That is pretty bold, but he was right. But here's the problem. He was right, and then his problem was his proof was not necessarily right, but he then said, but I don't have room in my notebooks to show you how. Remember, with mathematicians at this point, when you make a claim, people are like, we want to see your proof, and then you're like, but I don't have room to explain it. So for 300 years, mathematicians tried to find the answer. For 300 years. And then one day, back in maybe, let's say, the 60s or 70s, a young British boy decides, he sees this problem, and he says, I'm going to find the answer. So before I tell you what he did, I want to repeat what the problem is. What is the problem? The problem is Pythagoras' theorem, which is a squared plus b squared is equal to c squared, does not work for anything greater than squares. There is no number in the universe raised to the fourth power plus another number raised to the fourth power that will give you a number to the fourth power. There's no number to the fifth power plus the fifth power that will give you an answer to the fifth power. Sixth power, seventh power, all the way till forever. There's none. It will only work for squares, and that's it. So Andrew Wiles was about 9, 10 years old. Right? So if you haven't caught the memo now, I don't believe in grade-based math teaching. I don't. Because some of the greatest mathematicians were 14 years old when they did what they did. You can be a world genius mathematician at 10, 9, 8, 7. The youngest professor is like 9. It doesn't matter. Age is irrelevant. Math doesn't respect age. That's just the nature of math. So one message I have for math educators is we have to stop teaching math based on grade level. We do. Desperately need to stop. Because there was once a time where when you were in 4th grade, you only had access to 4th grade math books. Now, you all have access. If you have one of these gadgets, you have access to more than they had to take people to the moon. So this has leveled the playing field for everybody, right? So the youngest mathematician, look it up, Professor Isaac, I think. This boy is shorter than me, teaching students. He's 9 years old, professor of mathematics, right? So the point is, math and age don't matter. But this boy, Andrew Wiles, saw the problem, and he's like, I'm going to solve that. He was very young. And he went on to Cambridge, which we visited last year, and God willing, I hope most of you can go to Cambridge someday. But he went to Cambridge, and this boy, one day, said, well, he became a man. He went to Cambridge, he got his PhD in math, which is a lot of math. A PhD in math can take you 10 years. So anyways, a PhD in math, and then he tells the world, I have the solution of Fermat's last theorem. So guess what? You know how people rush to see celebrities? That's how, this is a math celebrity at this point, right? I know most of you only know celebrities who sing songs, and unfortunately, sometimes I question those songs. But let's forget about celebrities who sing nonsense songs for a second. And let's talk about a true celebrity, okay? This guy comes and everybody's like, show us the proof, and he shows the proof. And there was some mistake somewhere, but he showed the proof, and the world is all watching. You know where he did the proof? In Cambridge. Why is Cambridge important? Because Cambridge is this university in England which gave rise to the following names you might know. Isaac Newton. They also have Andrew Wiles, who's a big deal. He's well accomplished. They also have another person. I don't agree with this person philosophically, but physics-wise, he's also known as a big name, and that's Stephen Hawking. So again, you might not agree with, this is a guy in the wheelchair that was made from MIT. You might have seen him, and the computer talks for him, right? So that's Stephen Hawking. He did pass away a few years ago. There's a whole movie about Stephen Hawking's life. Stephen Hawking actually took the position that he was called the location professor of physics, which is actually the position that Isaac Newton had back in the day. And remember, Isaac Newton is a boss. We don't need to go into detail about him today. Today's not English Day, but Isaac Newton is a boss, right? He's one of the co-founders of a field of study called calculus. And also, we talk about physics. And Newton comes from that tradition, right? Newton is if Newton was just a mathematician, he would be like the boss. If that's all Newton did, he would be the greatest mathematician. Okay, he's tied for number one with Leonard Euler and Carl Friedrich Gauss. If that's all he did, he would be number one. If the only thing Newton did was physics, he would be number one. Until Einstein came, as far as Newtonian physics. But he did both. So Newton is number one here, and he's number one here. It's like me being LeBron James in basketball and Lionel Messi in soccer. And I'm the same person. Can you imagine that for a second? Like, LeBron James is, and I'm not a LeBron fan, but he is the greatest of many things, right? Lionel Messi is like the greatest in soccer, right? One of the greatest. You can argue about Cristiano Ronaldo. I think you're wrong. But the point is, Lionel Messi is like the best. Isaac Newton is like the best in both. So when Andrew Wiles, well, again, he's tied. He's not number one alone in that sense. Andrew Wiles gives this presentation, and eventually the proof is found to be solid. So this is true. There is no number raised to a power greater than a square that will give you the answer. So don't even bother. Don't even bother trying to find it, because they've shown it beyond a shadow of a doubt as truth. So that leads me to the question, what is mathematics? What is mathematics? Well, mathematics is a field of study that focuses on making sense of quantity and pattern recognition. So mathematics tries to make sense of quantity, or how to classify quantities, and also dealing with patterns. I'm not the only one who believes in most of that definition. Another man by the name of Leonard Euler, who was Swiss. Leonard Euler, Isaac Newton, and Carl Friedrich Gauss. Okay, Gauss with a G here. Carl Friedrich Gauss, Isaac Newton, Leonard Euler. These guys are generally ranked as the best mathematicians ever. And what's interesting about them is that these two were not really prodigies. Why is that important? Because your story doesn't matter for mathematics if you work hard. It doesn't matter. These guys were the best, but they worked hard. Now, granted, this guy probably went to college at 13, 14, but still, okay? That's not like this guy. This guy was a prodigy. This guy was strange in a good way, but he was strange. At the age of 8, apparently the story is told that this guy is sharp, he's causing trouble. Well, not causing trouble, but like he knows the stuff happening in class, and the teacher tells him, why don't you just add 1 plus 2 plus 3 plus 4 to 100? Go do that and sit in the corner. He had the answer in a second. The teacher said, how could you know the answer? And he said, well, if you take a number and you multiply it by that number plus 1 and divide it by 2, you get the answer. But you're 8. You shouldn't know this. You shouldn't come up with formulas on the spot. That was the kind of guy he was. And some of the math that he came up with, we teach it here in calculus. Now, this is not to make any of you feel bad about your math ability. No, this is to tell you that, yes, there's prodigies. They exist, but they're rare. This is more common. These guys worked hard, and they sought to master the material that they learned, right? Newton lived from 1642 to 1727, and Euler lived from 1707 to 1783. That's the timeline we're dealing with, okay? So the 1600s, the 1700s, Fermat came around that time as well. So the first thing I wanted to do today was establish what is mathematics, who is an influential French mathematician, Pierre de Fermat, right? And then I'm going to lead you to another famous mathematician, and then we'll land our plane and take a break shortly. We'll take a break here in about 10 minutes. Okay, so we've looked a little bit at the history of mathematics, we're going to go back and do a little bit of mathematics, okay? So let's talk about a mathematical principle. And then what I want to do is I'll lead that back to another famous mathematician by the name of Blaise Pascal, and then we'll land our plane. So, what is the famous concept? In your notebooks, I want you to do me a favor. I want you to draw a table for me, like this. In this table, we're going to make squares and cubes. So what is a square and a cube? You're going to write the number 1, you're going to write the number 2, number 3, number 4. Why don't we go all the way down to the number 12? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. You guys are going to discover something today that might make you go, wow, I didn't know that. That is strange. Well, you'll find out. So I'm going to actually help you to discover this today. I discovered this after college, but now you get to discover it before. So go ahead and write 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. And then over here, let's write 1 times 1 and write the answer right there too. And actually for simplicity, we're only going to do it like this, 2 times 2 and then 4. And then the next one down, just write the number 9. You don't have to write 3 times. You just write what is the answer if you do that. So let's go ahead and do that. So 1 to 12. And then what is 1 times 1, 2 times 2, 3 times 3, 4 times 4, all the way to 12 as well. Okay? So let's go ahead and do that. And then I will show you a pattern that exists between squares, cubes, and then we'll talk about Blaise Pascal. So before I go on, let me see. While you do that activity, I'm going to pause. And then, so Elias, we're going to pause and I'm going to just clean the board. So, yes? What were we supposed to do? So go ahead and write down, make a table. In your table, you